Alright, welcome everybody. Today in this video I'm going to be explaining IPSEC main mode messages, specifically IKE version 1. Okay, so I'm your host, CCNP Seth, so let's get into it. Now in IKE version 1, there are 6 main mode messages that are exchanged. This is compared to the aggressive mode, which only uses 3 messages. So the trade-off between main mode and aggressive mode is one takes longer, clearly because of 6 messages, and it hides the peer identities. So if someone was eavesdropping, they wouldn't see who was actually establishing the IKE version, the phase 1 tunnel. If we use aggressive mode, since there's only 3 messages, it is a shorter exchange, but it will expose the peer identities. So that's the trade-off. Now when I go through these messages, I'm going to say message 1, message 2. All odd messages are sent by the initiator, and then all even messages are sent by the responder. Okay, so I have GNS3 up, and this is what we're going to do. I'm going to create a tunnel, a GRE tunnel, and I'm going to encrypt it with IPSEC, and I will capture the messages that flow through it, and we will break down all 6 of these messages. Okay, so Wireshark is starting up. And I already have the configurations pretty much pre-built. All I'm going to do is copy and paste them in. But if you want to see what it is, these configurations, just go ahead and pause the video. I'm not going to get into how to actually configure IPSEC, but all of these configurations are here. So I'm just going to paste this in. This is going to be the left side. This is going to be the initiator's configurations. And I got an error real quick. Oh, because it says IPSEC. That's wrong. Okay, just a second. Let me fix this. I'll change this. I spelt that wrong. It's fine. Hit the up arrow. We'll do no. And then paste it in. There you go, that should work. Okay, that side is good. Let me edit this config and we'll do it on the other side. 2, 1, 1, and 2. There we go. Paste this on the other side, and we should be good to go. Whoa. Alright, let me see if I could ping the other side, the other tunnel. And we got 4 out of 5. Let me double check my Wireshark, wherever it's at. Let's get rid of some of these things here. Not selected, not selected. Okay, here we go. How do I make this smaller? Okay, so it looks like we have the 6 messages, and then we also have quick mode. This is IPSEC phase 2. So we should have 6 messages here for phase 1. This is the IKEv1 phase 1. 1, 2, 3, 4, 5, 6, 7 it looks like. Looks like this was probably the first time I set up IPSEC on the other side. It was probably trying to establish a tunnel, but these are probably our initial 6 right here. Okay, so let's get into what these messages look like. So the first message is it proposes policies by sending 1 or more security association proposals. So when I was configuring the policy, here is the policy. So what I'm doing is I'm actually sending this type of IPSEC policy saying, hey, I want to create this phase 1 tunnel with these parameters, and the phase 1 tunnel should actually have this information in there. So let's go into Wireshark and let's take a look at it. Notice here that the initiator has this SPI, this security parameter index, I believe. I believe that's what it is, and it is just a simple hash value. Okay, kind of like to identify themselves, and I'll go back to the slide that identifies all that. But let's look at the payload proposal. Okay, so this right here is everything that I put in the actual configuration. Right here. See how it says encryption 256 hash SHA-512. All of that stuff is in here. So I'm trying to tell the other side, hey, I want to create a phase 1 tunnel with you. Here are the parameters that I want. You can also see the Diffie-Hellman group, which I chose 14, which is right there. Okay, so this is from the initiator. We know it's from the initiator because we don't have a responder SPI yet. But if we go to the next message, we see that, we do have the initiators SPI, we have the responders SPI, which is a quick hash algorithm. And if we look here, the second message is in response from the responder to the packet sent from the initiator. The purpose of this second message is to inform the initiator of the security association attributes which are going to be used. The fields are going to be the same, and here is that SPI hash value. So that initiator and responder must calculate a value. This is sometimes called a cookie. And the cookie is used to protect the IPSEC peers against denial of service attacks or replay attacks. And this hash is based on the IP source destination address and the source and destination ports, along with a generated secret random value. Okay, so those are the first two messages. It's basically just saying, hey, these are the security association parameters that I want to build a tunnel on. Second message says, yes, I can support that. Then we move on to the third message and the fourth message. So the third message, again, since it's odd, it's going to be the initiator sending this. So from the initiator to the responder, message contains the Diffie-Hellman key exchange payload and a nonce payload. This exchange uses the Diffie-Hellman exchange to generate shared secret keying material used to generate the shared secret keys. Okay, so I'm not going to go big into Diffie-Hellman, but based on that group number that I set, I now have that same color paint that we are going to use to start our exchange with. And then I'm going to give you my public key, quote unquote. Okay. And then the fourth message is going to be from the responder to the initiator. It's basically going to be the opposite of the third message, but it's going to be from the responder. Now this nonce value, this nonce payload, and we're going to take a look at this. A very large number, and it is used to calculate keying material. It is also used. It is also sent to other parties. Sent to the other party, signed and returned to prove their identity. So this nonce value is another type of authentication payload value. Now if we go back to Wireshark, we'll look at this third value. 1, 2, here you go. So we get to see here, there is that nonce value, there it is right there. Oh, I'm sorry. This is the key exchange. This is the Diffie-Hellman key right there. This is that shared secret keying material. And then we have the nonce payload. Okay? And then we have some other types of payloads here. We have a vendor ID payload, so on and so forth. Okay? If there is NAT, this is where they will discover if there is, if NAT traversal needs to be implemented, but we're not using NAT here, so those values, they're not important at the moment. Okay, so again, the third and fourth message, this is where Diffie-Hellman is exchanged. Then we move on to the fifth and sixth message. Now in between the fourth and fifth message, since both parties got the Diffie-Hellman secret keying material, now we could actually calculate our shared secret, and that is what we are going to use to encrypt messages 5 and 6. before messages 1 through 4 were unencrypted because we haven't found that shared secret. But after Diffie-Hellman was completed, now the 5th and 6th messages are encrypted and we can't see the peer's identity. So in the 5th message, 3 keys are generated by both peers for authentication and encryption. The 5th message contains the identification payload, the hash payload, and the identification payload and hash payload are used for identification and authentication. So now in the 5th and 6th message, we are actually using these messages to identify and authenticate each side. And we're doing it in an encrypted fashion. Okay? Now if we go to Wireshark, this is the 4th, this is the 5th, and then, I'm sorry, 1, 2, 3, 4, 5th. Here we go. See how it says next payload identification? If we look at this 5th message, I can't see anything. All I see is the initiator and responders hash value, that SPI, and that's it. Look at this, encrypted data. I can't see anything else. I don't know who on the other side is actually creating this tunnel. And if we look at our configurations, the IP addresses of the peers, or the peers, is the tunnel right here. So that is, and we're protecting our GRE tunnel with IPSEC. So this is where we're exchanging our identity, peers, and things like that. Okay? Yeah, and messages 5 and 6 are encrypted. See? Encrypted. Now that we established phase 1, this is where phase 2 comes into play. This is where the actual IPSEC tunnel is built. Once this second phase 2, or this phase 2 tunnel is created, phase 1 tunnel can go away. But this video is just strictly on the 6 messages in main mode, and maybe I'll do another video on these last 3 messages here. So this is basically what I just said. Phase 1 is now complete, and now phase 2 can be started, could be started to form the IPSEC tunnel. And again, this is what uses quick mode. Okay, so I hope this gave you a better understanding of what main mode does and where the Diffie-Hellman exchange comes into play. This caught my eye. I really wanted to dive deep into these messages, and the only way for me to remember this is if I make this video. So I hope this was informative for you, and I'd like to thank you for viewing.